March 1945. The Saarland, Western Germany. A Sherman tank rolls forward carrying something unnatural on its roof. 60 steel tubes stacked in rows, aimed at a tree line 800 yards away. The tank commander presses a switch. What comes next is not a gunshot. It is a shriek, a howling, layered scream, like a steam organ tuned for war. 60 rockets leave their tubes in under 30 seconds. The tree line vanishes. This is the story of the T34 Calliope, a 60-tube rocket launcher bolted to the roof of the most produced American tank of the Second World War. It was built for the single most important day of that war. It missed that day entirely. And when it finally reached the battlefield 10 months late, it carried a secret its designers never intended. The weapon's greatest power was not what it hit. It was what it sounded like. But to understand why the United States Army strapped 60 rockets to a Sherman, you have to understand the problem that no existing weapon could solve. By 1943, Allied planners preparing for the invasion of northern France faced a gap in their firepower that nothing in the arsenal could close. The beaches were defended by concrete bunkers, machine gun nests, trench systems, and anti-tank obstacles spread across hundreds of yards of open sand. Naval guns could soften those defences from miles offshore. Heavy bombers could crater the landscape from altitude, but neither could deliver concentrated close-range saturation fire during the critical minutes between the last naval shell and the first infantry boot touching the sand. What the planners needed was a weapon that could ride ashore with the tanks, point at a section of beach, and erase everything on it in half a minute. The problem was that America's best ground-launched rocket was not designed for the ground at all. The 4.5-inch M8 was an air-launched weapon, originally built to fire from fighter aircraft diving at several hundred miles per hour. At those speeds, the rocket's small stabilizing fins worked. The airstream kept it straight. Fire the same rocket from a stationary launcher at a fraction of that velocity, and the fins could not hold it. The M8 wandered. At maximum range of roughly 4,000 yards, half of all rockets fell inside an ellipse measuring 65 by 130 yards, an area the size of a football field. For a weapon expected to destroy specific bunkers, this was useless. The engineers at Aberdeen Proving Ground arrived at a solution that was blunt, logical, and deeply American. If one rocket could not hit a target, fire 60 at once. Saturate the area so completely that accuracy became irrelevant. Turn the rocket's worst flaw into the weapon's defining feature. The result was the T-34 rocket launcher, a frame holding 60 launch tubes bolted directly to the turret roof of an M4 Sherman tank. They named it after the Calliope, the steam-powered circus organ whose clustered pipes it resembled. The name was charming. The sound it made was anything but. The designer behind the Calliope was Victor Hawkins, working out of Aberdeen Proving Ground in 1943. What Hawkins created was a weapon that embraced a fundamental truth about rockets, and turned it into a system designed around the admission that no single rocket in the American inventory could reliably hit anything smaller than a city block. Each M8 rocket weighed roughly 38 pounds and carried between 4 and 5 pounds of TNT, comparable to the explosive filler inside a 105mm howitzer shell. Multiply that by 60, and a single Calliope salvo delivered the blast equivalent of an entire artillery battery firing at once. The rockets left their tubes in a ripple sequence controlled by an electrical firing panel, all 60 departing in approximately 20 to 30 seconds, each trailing white smoke and a shriek that multiplied into a continuous wall of noise as the salvo built to full force. The tube arrangement was deliberate. An upper bank of 36 tubes sat in 2 rows of 18 across the top of the turret. 2 lower banks of 12 tubes each flanked the sides and could be jettisoned independently after firing. The entire assembly weighed 1,840 pounds and sat roughly 3 feet above the turret roof, high enough to transform the Sherman from a familiar silhouette into something alien and unmistakable on any battlefield. The original T-34 used tubes made from plastic fibre, sometimes described in records as treated plywood. These degraded after just 2 or 3 firings, warping under the heat and blast pressure of the rocket exhaust. The weapon was, from the start, designed to be disposable. Fire once, drop the empty frame, revert to a standard tank. But the engineer's obsession that truly defined the Calliope was its elevation mechanism and the flaw it introduced. Hawkins connected the launcher to the Sherman's 75mm gun barrel with a split ring clamped directly around the tube. This allowed the launcher to track with the gun's elevation, plus 25 degrees to minus 12, without any separate aiming system. It was an elegant solution to a difficult mechanical problem. It was also a disaster. The main gun could not fire. Any recoil would transmit directly into the launcher frame, risking catastrophic structural failure or sending the entire assembly crashing off the turret. Tank crews were forced to choose between their rockets and their primary weapon. They could not use both. The firing cables added another indignity. They ran from the launcher down through the tank commander's open hatch to a control panel inside the turret. The commander operated the weapon with electrical wires draped across his lap and his hatch unable to fully close, exposed to shrapnel, weather, and anything else falling from the sky. Frontline crews eventually solved what the engineers had not. They welded a metal plate to the armoured lips of the gun mantler and reattached the elevation ring to this non-recoiling surface, freeing the barrel to fire independently of the launcher. This field modification was so effective that the Army formalised it as the T34 E1 variant, which also replaced the failing plastic tubes with more durable magnesium ones. The men who fought with the weapon fixed it faster than the men who designed it. And still, none of this mattered, because the weapon's greatest problem was not mechanical, it was timing. Approximately 200 Calliope launcher assemblies were manufactured and shipped to Britain in early 1944, purpose-built for Operation Overlord. The plan called for rocket-armed Shermans to ride ashore in the first wave, saturating German beach defences with 60 rockets per tank in the minutes before infantry crossed the sand. It was exactly the weapon the beach assault demanded. The plan was killed by physics. The 1,800-pound launcher, mounted 3 feet above the turret, raised the Sherman's centre of gravity to the point where the tank became dangerously unstable on the flat-bottomed landing craft that would carry it across the English Channel. In the rough swells of the Channel, a near certainty in early June, a top-heavy Sherman risked capsizing the craft or sliding off the deck entirely. The proposal was rejected without formal testing. The instability was obvious enough from engineering analysis alone. The weapon built for the most important amphibious invasion in history was disqualified because it was unsuitable for amphibious operations. The 743rd Tank Battalion, the very unit that would later receive Calliope launchers, landed on Omaha Beach in the first wave on June 6, 1944. The weapon designed for that exact moment sat in a British depot 300 miles away. 6 months passed. In December 1944, the Calliope received a second chance. 30 Shermans of the 743rd Tank Battalion had launchers installed for a planned offensive near the Roa River, supporting the 30th Infantry Division. Meanwhile, a separate ordnance company mounted Calliope launchers onto 5 captured German half-tracks using repurposed anti-tank gun mounts, creating a hybrid vehicle that was test-fired once and photographed 24 times for the historical record. Then the Germans launched their Ardennes offensive on December 16th. The Roa River plan was cancelled overnight. 30 launchers were stripped from 30 tanks without a single rocket being fired. The half-track hybrids never left the depot. It may have been the largest logistical effort of the war to deploy a weapon that accomplished absolutely nothing. A lot of these stories don't get told anywhere else. Subscribing helps make sure we can keep telling them. Now back to the Calliope. The weapon finally reached combat in March 1945, when General George S. Patton's Third Army drove through the Saarland into western Germany. Launchers were distributed across the 2nd, 4th, 6th, 12th and 14th Armoured Divisions, along with several independent tank battalions. The 737th Tank Battalion's after-action report from that month records 4 rocket tanks, 3 from Baker Company and 1 from Charlie Company, supporting the 5th Infantry Division's advance through the Eifel region. After 10 months of rejection, cancellation and storage, the Calliope was about to make the sound it was designed to make. But the men who fired it discovered something the designers never warned them about. The Calliope's honest limitation was not its accuracy. Crews expected the rockets to scatter. The limitation was that it could not hide. The launcher added 3 feet to the Sherman's profile and transformed the most common tank on the Western Front into the most recognisable one. Every German gunner within a mile could tell the difference. Glenn Lamb knew this. A tank commander in the 714 Tank Battalion, 12th Armoured Division, Lamb drove an M4A3 named Coming Home with the word Persuader painted on the gun barrel. His account of Calliope operations in the Saarland, preserved by his son, describes the grim arithmetic of visibility. The Calliope tanks hung at the back of every column. The standard Shermans rolled down a road without drawing fire. The Germans waited. When the Calliope appeared, towering, unmistakable, they opened up with 20mm anti-aircraft guns aimed horizontally at the exposed tubes. One of Lamb's closest friends was killed exactly this way. The Germans had learned to hold fire and save it for the one Sherman that mattered. Historian Stephen Zaloga documented the broader resentment. Tank commanders felt the rocket mission belonged to artillery units, not to tank crews who were now carrying the tallest target in the column. The weapon that could not hide had to justify its exposure with results, and the results, 60 rockets shrieking into a position in half a minute, were precisely that justification. The same towering profile that drew fire also delivered the weapon's greatest asset, psychological devastation. Every German soldier within earshot knew what was coming. The sound preceded the impact by seconds. In those seconds, men stopped fighting. The weapon that could not be concealed did not need to be. It needed to be heard. The T34 Calliope was decommissioned by 1946. Most launcher assemblies, designed from the start as temporary disposable bolt-on equipment, were scrapped within months of the German surrender. The Army tested a successor, the T-99 rocket projector, on the M26 Pershing tank in late 1945. The T-99 addressed every Calliope shortcoming: enclosed armoured tube mounts that did not betray the tank's identity, independent elevation that freed the main gun, and a hydraulic jettison system that worked reliably. It was cancelled in post-war budget cuts before entering production. The Calliope's conceptual legacy outlived the hardware. America's first serious experiment in vehicle-mounted saturation rocket fire fed 4 decades of development that would produce the M270 multiple launch rocket system in 1983 and the M142 HIMARS that has reshaped modern battlefields from the Persian Gulf to Eastern Europe. The modern MLRS crew fires 12 guided rockets from an armoured vehicle and relocates before the enemy can respond, a doctrine whose earliest, crudest ancestor was 60 unguided rockets bolted to the roof of a Sherman. One wartime photograph, published in RP. Honeycutt's definitive reference on the Sherman tank captures the spirit of the men who operated this weapon better than any after-action report. It shows a Calliope-equipped M4 wearing field-applied concrete armour, mismatched track connectors from months of hard service and battlefield repair, and, mounted on the front hull, a bust of Adolf Hitler fitted with a cap, serving as a hood ornament. The crew responsible was never identified. The image survives as proof that the men who drove into combat carrying the tallest target in the column did so with exactly the kind of dark humour that keeps soldiers alive. No confirmed complete Calliope, launcher mounted on its Sherman, survives in any museum in the world. The 12th Armoured Division Memorial Museum in Abilene, Texas holds photographs. The National World War II Museum has Signal Corps images in its digital archive, but the physical weapon is gone. The disposable tubes were jettisoned in the field. The frames were scrapped in the piece. Of roughly 200 built, not one has been positively identified as intact. 60 tubes. A steam organ tuned for war. The weapon is gone, but the sound of it never left. The weapon the war almost didn't need, until the war needed exactly what it was. The Calliope was designed for the beaches of Normandy and rejected before it could fire a shot. It was installed for the Roer River and stripped before it could fire a shot. It finally fought in the Saarland, 10 months late, with a profile that invited every German gun in range, firing rockets that could not hit a barn from the inside, and yet, when 60 of those rockets left their tubes at once, nothing on the receiving end stood its ground. If you had been a tank commander in Patton's Third Army in March of 1945, would you have volunteered for the Calliope, 60 rockets and the tallest silhouette in the column, or would you have let someone else make that sound? Tell us in the comments, and don't forget to subscribe.